MAX96x, MAX99x, ultra-high speed, beyond the rails comparators. Maxim. Welcome to this training module on Maxim's MAX96x and MAX99x ultra-high speed, beyond the rails comparators. This training module provides an overview study on single, dual, quad, ultra-high speed, plus 3 volts and plus 5 volts, beyond the rails comparator families. The MAX961 through MAX964 and MAX997 and MAX999 are low-power, ultra-high-speed comparators with internal hysteresis. These devices are optimized for single plus 3 volts or plus 5 volt operation. The input common mode range exceeds 100 millivolts beyond the rails, and the outputs can sync or source 4 milliamps to within 0.52 volts of ground and VCC. Propagation delay is 4.5 nanoseconds, 5 millivolt overdrive, while supply current is 5 milliamps per comparator. The MAX961, MAX963, MAX964, and MAX997 have a shutdown mode in which they will consume only 270 microamp supply current per comparator. The MAX961 and MAX963 provide complementary outputs and a latch enable feature. Latch enable allows the user to hold a valid comparator output. The MAX999 is available in a tiny SOT23-5 package. The single MAX961 and MAX997 and dual MAX962 are available in space savings 8-pin Micromax packages. Here lists the application fields where this device can be used. It can go into single 3 volt or 5 volt conversion systems, battery powered operated systems, threshold detectors, GPS receivers, line receivers, zero crossing detectors, high-speed sampling circuits, to name a few. This page shows in brief about different members of the MAX9XX comparators, along with the key specifications like number of comparators in each package, whether it has a shutdown function, the latch enable function, etc. Most high-speed comparators oscillate in the linear region because of noise or undesirable parasitic feedback. This can occur when the voltage on one input is close to or equal to the voltage on the other input. These comparators have a small amount of internal hysteresis to counter parasitic effects and noise. The added hysteresis of the MAX961 through MAX964, the MAX997 and MAX999 creates 2 trip points, one for the rising input voltage and one for the falling input voltage as shown in the figure. The difference between the trip points is the hysteresis. When the comparator's input voltages are equal, the hysteresis effectively causes one comparator input voltage to move quickly past the other, thus taking the input out of the region where oscillation occurs. Standard comparators require hysteresis to be added with external resistors. The fixed internal hysteresis eliminates these resistors. The MAX961 and MAX963 include internal latches that allow storage of comparison results. The latch enable has a high input impedance. If latch enable is low, the latch is transparent. The comparator operates as though the latch is not present. The comparator's output state is stored while latch enable is pulled high. All timing constraints must be met when using the latch function. The MAX9XX comparators include internal protection circuitry that prevents damage to the precision input stage from large differential input voltages. This protection circuitry consists of two groups of 3 back-to-back diodes between N plus and N minus, as well as two 200 ohm resistors. The diodes limit the differential voltage applied to the comparator's internal circuitry to no more than 3 VF, where VF is the diode's forward voltage drop. The MAX961 through MAX964, the MAX997 and MAX999 contain a current-driven output stage as shown in the figure. During an output transition, I source or I sink is pushed or pulled through the output pin. The output source or sink current is high during the transition, creating a rapid slew rate. Once the output voltage reaches VOH or VOL, the source or sink current decreases to a small value, capable of maintaining the VOH or VOL state. This decrease in current conserves power after an output transition has occurred. One consequence of a current-driven output stage is a linear dependence between the slew rate and the load capacitance. A heavy capacitive load slows down the output voltage transition. Here is an example application which is a level shifter from 3-volt logic to 5-volt logic. As shown in the figure, this circuit requires only a single comparator with an open drain output. The circuit provides great flexibility in choosing the voltages to be translated. It also allows the transition of bipolar plus or minus 5-volt logic to unipolar 3-volt logic by using the MAX972. In that application, take care that no voltage exceeds the maximum voltage allowed on any pin and that the current into the output is limited by a sufficiently large valued pull-up resistor. The MAX961 through MAX964, the MAX997 and MAX999 high bandwidth requires a high-speed layout. Here lists these layout guidelines.